All right, good people, here we go. We're looking at example 4. Example 4 switches it up a little bit because the graph that they give us is not the graph that they're asking about. So let's read the setup here. A function g is differentiable on the closed interval between 0 and 6. The graph of g prime, the derivative of g, is given above. At which x value does the graph of g have its absolute maximum value? Okay, let's break this down. G is differentiable. If you can find the derivative of g on the closed interval, that means g is continuous on the closed interval between 0 and 6. So we're good. Not only that, I can see the derivative, and the derivative is defined everywhere between 0 and 6, including at 0 and 6. Great. So now we go to the next part. Can you find the critical values? The critical values are going to occur wherever the derivative, wherever g prime is equal to 0. Well, this is the graph of g prime, so it's going to occur here and here and here. So that happens at x equals 0, x equals 4, and x equals 6, which includes the endpoints, right? So if I were to build my table of x values and g values, I would say at 0, at 4, and 6, and then I would try to find the g values. The problem is we don't have enough information to find the actual value of g at x equals 0, the actual value of g at x equals 4 and at 6. So instead, we're going to be a little bit sneaky about this. Remember what the derivative tells us. If g prime is greater than or equal to 0, that means g is increasing. Well, the derivative is greater than 0 here. Let me use a different color. Between here and here, the derivative, which is this graph, is greater than 0. So that means g is decreasing from 0 to 4. And then we know that if g prime is less than or equal to 0, then g is decreasing. Well, that would happen here. So if the graph, the original graph of g, is increasing from 0 to 4, and then it's decreasing, so if the graph, the original graph, is increasing from 0 to 4, and then decreasing from 4 to 6, well then this must be the absolute maximum. Regardless of where it starts, like it doesn't have to start at 0, right? It could start over here, but if it's increasing and then it's decreasing, well then the highest point has to be at 4. It's the only critical value, right? So we're going to say at which x value does the graph have the absolute maximum? G has its absolute maximum value at x equals 4 because g prime changes from positive to negative at x equals 4. That is to say, g changes from, so you don't need to write this part, g changes from increasing to decreasing at x equals 4. So because there's only one point in between my endpoints, right? These two are my endpoints. There's only one point in between, and at that point, that is a critical value because the graph goes from increasing to decreasing. Then it has to create this behavior where there has to be a maximum, and that must be the absolute maximum there. Okay. Example 4 showed us if we use what we know from previous sections, we might be able to find the answer in a slightly different way. When I go to example 5, we go back to finding both the maximum and minimum values of k. K is given to us in an equation, so we're going to need to find the derivative of k. So k prime is the derivative of e to the sine x. Well, the derivative of any exponential is the exponential itself times the derivative of the exponent, which would be times cosine of x. But I want to know where this is equal to 0. because it's never undefined, by the way. Well, exponentials are never equal to 0. However, this might be equal to 0. So the question is, when is cosine x equal to 0? Specifically, in this interval between 0 and pi. For what angle is the cosine of the angle equal to 0? Excuse me. I believe that would be at x equals pi over 2 and 3 pi over 2. At those two values, the cosine of pi over 2 is 0, and the cosine of 3 pi over 2 is also 0. So I have my critical points. These critical values I'm now going to use along with my endpoints. So my x column is going to include my endpoints, my critical values, and then my other endpoint. What are we going to evaluate? We're going to evaluate k. So we're going to evaluate using this, right? So that's going to be, so we're using the original function k, e to the sine of 0. Well, sine of 0 is 0, so e to the 0, that's going to be 1. E to the sine of pi over 2. Well, sine of pi over 2 is 1, so then this is just e. E to the sine of 3 pi over 2. Well, sine of 3 pi over 2 is negative 1, so that would be e to the negative 1, and that's a fraction, 1 over e. And then e to the sine of 2 pi, and sine of 2 pi is 0, so e to the 0, and that's going to be 1. All right. So now the question is, what is the biggest value? What is the smallest value? Well, remember that e is about 2.718. So already this is the highest value between the endpoints. It's bigger than the endpoints. And actually, that is going to be the absolute max. The absolute max is e at x equals pi over 2. E. The absolute minimum has to be a fraction because that's smaller than 1. So then the absolute minimum is 1 over e, and that happens at x equals 3 pi over 2. And we found our max and min values. So both of these questions, again, are asking us to find extreme values, absolute maximums and absolute minimums. When we're given an equation, we can find the critical values by taking the derivative and finding out when the derivative is equal to 0 or undefined, and then testing not only those, but also the endpoints to figure out where the biggest output is, the absolute max, where the smallest output is, the absolute min.